Welcome to your weekly introduction video. This is not too much work to do this week, so hopefully you can get it done quick, and maybe you could do a bit of a past paper exam practice this week. So we're going to finish off some of our work on trigonometry, and we're going to look at a little bit of three-dimensional trigonometry, and we're going to look at the sine, cosine and tan functions and what their graphs look like. Okay, so we need to be able to find the angle between a line and a plane, be able to find the angle between two planes, and understand the graphs of sine x, cos x and tan x, and use those graphs to find obtuse and reflex angles. Okay, now so we're just going to start off with a bit of three-dimensional trigonometry. Okay, actually what I'm going to do, I'm just going to try and make this picture a little bit bigger. Sorry, not this one. Just going to try and make this a bit bigger so we can look at it. Okay. Right, now, what are we actually being asked for here? Oh, sorry, hang on, let me just move it again. Move it down there. Okay, so it says find the angle. Oh, I haven't done any. Sorry about this, guys. 1 second. Too big. There we go. Okay, so we've got to name the angle between the following line segments and the base plane. Now, what do they mean by a plane? Let's first of all just try and understand that. So the base plane is this area here. Okay, a plane is a flat two-dimensional surface. Okay, a flat two-dimensional surface. So this is your base plane. Okay, so the base plane we could describe as E, F, G, H, this shape here. Okay, that's a plane. And we are wanting to also know what the line segment AH is. Okay, but this is the line AH. Okay, so what we're going to do is try and find out what the angle between that line segment and the base plane is. Now, what I want you to do is imagine that you're going to take this line here, the line you want, and imagine it casts a shadow underneath onto the plane. So imagine the sun is up here shining away. Okay, and it casts a shadow from the line segment that you want onto the plane that you're interested in. And that is the angle that you're actually being asked to calculate, this angle here. So the angle you actually want to know is angle AHE. Okay? Right, what about the angle between the base plane and the AG? Let's just delete it again. Okay, so here's my base plane. Okay, so let's just shade that in. And we also want the angle, want the line segment AG. Well, that is here. Okay, imagine a shadow is being cast from directly above. Below AG, it would cast a shadow that looks like this. So the actual angle that we want to know is angle AGE. Angle AGE. Okay, so I hope that makes sense to you. So let's put that in the format of a little question. So it says find the angle between the following line segments and the base plane EFGH. So here's my base plane. Okay, and we want to know that between D and G. So let's put in DG. That's there. Now, if you imagine a shadow being cast right underneath, it would be there. So what we want to do is we want to find out the angle DGH. Okay, Now DGH should be easy enough to find. What we need to first of all is find the length of DG. Well, I know this is 4 centimetres, okay? So I can use a bit of Pythagoras. I think DG squared is going to be equal to the square root, DG squared is going to be equal to 4 squared plus 6 squared, which is 16 plus 36, which is 52. So DG is going to be the square root of 52. What I'm going to do is I'm going to leave my answer as root 52 because that way I can have things being accurate. Okay, so root 52. Now, if I want to know this angle, do you know what? Actually, I've wasted my time because I could have found that angle straight away because I already had 2 of the sides. So I could have said straight away that the tan of that angle is equal to the opposite side, which is 4, over the adjacent side, which is 6. Okay, so theta is equal to shift tan of 4 over 6. I'm just going to use my calculator. Shift tan 4 over 6. Making sure you're in degree mode. Then that angle is 33.7 degrees to 1 decimal place. Okay, what about BH? Again, let's draw in the plane that I'm interested in. Okay, so that's the plane there. And then draw in BH. BH, that's BH there. And then imagine a shadow is being cast onto the plane directly from above. So the angle that we actually want to know is BHF. BHF. Okay, this is a bit trickier this time because we don't know the length of BH or HF. But I'd say HF is very easy to calculate because we can use Pythagoras' theorem there. That's going to HF squared is 6 squared plus 5 squared, which is 36 plus 25, which is what, 61. So HF is equal to root 61. Root 61. Okay. So again, what we have, we can say if we want to know this angle here, tan of your angle, let's just write that in so it's clear, we're looking for this angle here, is equal to your opposite, which is 4, over your adjacent, which is root 61. And so theta is equal to shift tan 4 over root 61. Okay, I don't need to work out what root 61 is because I'll just use that in my calculator directly, get a more accurate answer. So 4 divided by root 61. Hold on a second. Shift tan 4 divided by root 61. And the answer, according to my calculator, is 27.1 degrees to 1 decimal place. Okay, so all you need to do is find out what angle you actually need to know, and then use a bit of Pythagoras maybe to find some missing sides of the right angled triangles, and then a bit of trigonometry to find your angles. Okay, nice and easy, I should hope. Okay, so here is a question for you to have a go at yourself. See if you can do it. Stop the video and then run the video, and I'll go through the answers. Okay, so what we've got to do, find the angle between the plane ABCD and the line XB. So let's draw in my plane. That's the plane I'm being asked for, ABCD. And the line XB. XB, there it is. Okay, so can we imagine a shadow being cast over XB onto the plane? It would be here. Okay, so the angle we want to know is XB, I suppose M would be the best one. Let's go XBM because that gives me a right-angled triangle. And that's what we want, a right-angled triangle. Okay, so we're going to have to find MB at the moment. We've got, here's my right angle. So we know the hypotenuse of that right-angled triangle is 12. This is the angle we're trying to find. So we also want to know the adjacent, which is MB. Well, MB is half of DB. And DB squared is equal to 8 squared plus 8 squared. 64 plus 64, which is 128. So DB is equal to root 128 using this right-angled triangle here. Okay, let's hope that makes sense. So MB is half of that, root 128 over 2. Okay. So now we can say, okay, we know the hypotenuse and we know the adjacent, so it's a cosine. So the cosine of my angle is equal to root 128 over 2 divided by my hypotenuse, which is 12. So my angle is root 128 over 2 over 12. Sorry, I messed that up. My angle is shift cosine of that number. So again, I'm gonna put that in. So shift cosine of root 128 over 2, and I'm just going to put divided by 12. And according to my calculator, that makes theta equal to 61.9 degrees to 1 decimal place. Okay, hopefully that makes sense. Right, let's do the other one. We need to find the angle between the plane and XY. Okay, so XY is this distance here. Imagine a shadow being cast underneath. Okay, would be there. Okay, that's where the shadow would be cast. So I can see a right-angled triangle. Let's draw it in. Be this one here. Okay, so what we need to do, well, what can we work out? We can certainly work out my. My is easy. My is equal to 4. It's xy that is difficult to know. We're going to have to use a bit of Pythagoras again. We've got another right-angled triangle here with this length 4 and this length 12, the hypotenuse. So we can say that xy squared is equal to 12 squared minus 4 squared. Hopefully you can see this right-angled triangle. So that makes sense to you. Okay, so xy squared is equal to 144 minus 16. So xy squared is equal to 128. So xy is equal to the square root of 128. Okay. So that means, so if we let's just put an arrow in there, square root of 128. That means we know this length being 4 and we want to find this angle. What we know again is the adjacent side and the hypotenuse. So the cosine of your angle is equal to your adjacent 4 over the hypotenuse root 128. So theta equals shift cosine 4 over root 128. So shift cosine 4 divided by root 128. And my answer is 69.3 degrees to 1 decimal place. Okay, So hopefully this is all making sense. You have to be able to think 3D. It can be quite difficult for some people. Okay, right. Stop the video and... Oh no, actually no, don't stop the video. We'll have to sort of work this one out ourselves, okay? So a square base pyramid has base length 6 centimetres and height 8 centimetres. Find the angle between the triangular face and the base. So let's try and draw this. Let's draw a square base, and we're told that it's 6 and 6, okay? What we need is to connect up. Okay, perhaps not the best drawing, but that doesn't really matter. Okay, and we're told that the height of this triangular base pyramid is 8 centimeters. So this distance is 8. Okay, what we want to know is find the angle between the triangular face. So let's call this triangular face here, doesn't matter which one we pick, and the square base. Okay? If that is the case, what you need to do is sort of find the center points of that. So what we're doing is we're finding this angle here. Okay? That's the angle between two planes. Okay? You've got the triangular plane and the square plane, and the black triangle is going to help us find out that angle. Okay, so we're trying to find out this angle here, and it should be easy to do because we know this distance is 3, we know this distance is 8, so we can use tan. Tan of my angle is equal to the opposite, which is 8, over my adjacent, which is 3. Theta is equal to shift tan of 8 over 3. Using my calculator, shift tan 8 divided by 3 is equal to 69.4 degrees to 1 decimal place. Okay, so you can find the angle between a line and a plane, but also between two planes, by just finding out which lines are going to help us do that. Okay, so I hope that that's pretty straightforward and pretty easy.